Faces away from your phones. Laptop lid's closed. There you go, that's the one. So, good afternoon, everybody. My name is Jeff Alexander. I'm a technical evangelist based out of the Microsoft Sydney office in Australia. And yes, Australia is losing everything at the moment, aren't they? I was watching this ad on the telly the other day, and it was about the Bledisloe Cup. And it was saying how Australia was going to get it this time. And I'm watching this going, you've got to be kidding me. You're not going to beat the All Blacks, dude. So Australia, they're right now, the Wallabies are in what they call a restructuring phase, or rebuilding phase, I guess is what they call it. So anyway, so today we're going to be talking about software-defined storage in Windows Server 2012 R2 and System Center 2012 R2. So how many of you guys went to the Green Hat session, which is Rick Clowes, on storage spaces? Okay, a few of you went to that one. So this session is going to be an all-up storage session about all the investments that we've made in storage, starting with the 2012 wave of products, and then what we've changed in Server 2012 R2 to get to this point of software-defined storage. So this is about being able to decouple the storage part away from your underlying infrastructure. So how many of you guys got SANs out there? Right? Anybody using JBODs at the moment in their environments? A lot less hands go up. So those of you that went to Rick's session, you would have saw the photos he had of some of the data on the Quanta devices. I'm going to show you a couple of demos from those devices so you can see what they're like. Now, storage is an interesting thing. Where you guys having an issue with storage demands increasing? And where do your users think you go and buy your storage? Dick Smith, yeah, run down to local Dick Smith, get some storage, away you go. They have no idea about how much storage actually costs or any of that kind of stuff. So, you know, we need to look at what we're trying to do with Server 2012 and also Windows Server 2012 R2 is to provide you with inbox tools to allow you to take advantage of commodity-based storage. Okay, so we're going to talk a lot about some of the features in that. We'll talk about storage spaces a bit, talk a little bit about dedupe and how that actually has changed in Server 2012 R2 around that. So that's a couple of the areas that we're focusing around to make sure, and how we're bringing storage under management in Virtual Machine Manager. Okay, so talking about how we're doing that. So first up, I want to talk a little bit about where we've been. If you were in the networking session, I did have a meltdown with my laptop. That laptop is so fried that I need to rebuild it when I get back to Sydney. So, well done. I think it was because Macca walked in the room and he totally jinxed my demo, but there you go. So there you go. So we're going to take the same approach that we had with networking. Talk about where we've been, road ahead, and then talking about storage management for the private cloud, bringing a lot of the learnings that we've had in our data centers around storage, and also looking at file-based storage, and particularly the scale-out file server role, and how we can actually manage that through System Center Virtual Machine Manager. Talk a little bit about storage spaces, but I'm going to show you a really nice demo of storage tiering in storage spaces and write-back cache. Now, Rick would have showed you guys how to actually set that up, to set it up for yourself if you want to test this in a lab yourselves. But what I'm going to show you is what's the impact, what are the results that you're actually going to get out for a particular workload. So we're going to show you a workload running and how the tiering and the write-back cache can help that workload. So I'll take you through and show you that as well. So we made a lot of investments. Again, in Windows Server 2012, on the storage side of things. I love storage. I've been dealing with storage for a long time. I go back to managing compact servers when I was managing servers in Microsoft's data centers. And we were doing a lot of stuff around storage. We had data that was growing at such an unbelievable rate. The best one I had is we used to use file classification internally at Microsoft to classify data, to get rid of data that was not used over a certain period of time. And I think in around about 2000 or 2001, 2002, somebody came to me and goes, hey, do you got all the files from the Windows 95 launch? And I'm going, really? So people do not get rid of data. They do not get rid of the data they store on there. And we had 60% of the data that we used in the environment had not been touched in 18 months. How many of you guys have data that's old and hasn't been used a lot? This is what's taking up a lot of the storage that we're using. People think that storage is really cheap, but storage is still a very big part of your IT investment when we look at how much we're actually spending on these types of devices. So storage is a big piece of that. We made a lot of investments to make storage a commodity, make it so that you could use commodity-based hardware. Now, I don't know if Rick talked about Facebook or any of the other vendors about what they do for their storage. But if you look at Facebook.com, they don't use any SANs at all. How many SANs do they use? 0. How many SANs does Azure use? 0. How many SANs does Google use? 0. They use JBOD enclosures that are much more flexible and give them the performance and the IOPS that they actually need for those types of workloads. But here's what we did in Server 2012. Take a quick look at that. How many of you are running Server 2012 today? All right, a few of you are using that. All right, so how many of you are using storage spaces today already? No hands go up. One person, good man. I might keep you in mind for that Nokia Lumia giveaway later on. So this is what the investments that we made in Server 2012 in regards to storage. We made a lot of improvements in storage. SMB3 was really the big piece that lights up storage in Server 2012. Being able to run scale-out file servers. We added a whole bunch of things, around 8,000 VMs per cluster. We integrated the iSCSI target server built into the operating system so that you could use that as your target. A whole bunch of things, cluster-aware updating, new file system called REFS that allows you to protect files from accidental deletion. So there's all these kind of things that we added in the actual storage part of the operating system. The new VHDX format. We can now scale a VHD file or VHDX file up to 64 terabytes. So there's a huge amount of improvement and scale in the storage piece. On System Center 2012 SP1, we've added a whole bunch of stuff around storage, around SAS array support, around storage pool classification, being able to classify storage based on, say if you have a gold tier of storage that has is a set of faster SSDs, you can classify it based on that and allow you to actually charge back from a private cloud scenario. So a whole bunch of things relate to storage in the 2012 wave. So if you're not, how many of you got 2003 out there still? Oh, wow. That's a lot. Looking to move pretty soon or not? Yes? Come to our sessions tomorrow. So these two guys up the front are going to do some migrating sessions to get you off that platform. When you think about storage, we're on a new release cadence now with our operating systems. We're now releasing yearly instead of 4 years and 2 years. Okay, so previously with Windows Server, we released an operating system, a major release of the OS every 4 years. And then every 2 years we did an R2 release. This started around Server 2003. Now we're on a yearly release cycle. Okay, so changes are going to happen faster. Changes are going to go a lot quicker. But you need to get to 2012 as your base from a storage perspective, and then you can start to add additional things with R2 as they come through. So lots and lots of work that's been done in regards to Windows Server 2012. Now we're going to cover dedupe a little bit later, but dedupe is amazing technology that allows you to really save a lot of space on those volumes. So maintain the existing investments that you have in disks without having to go and buy new hardware. Okay, so there's a whole bunch of things that we've actually done. What do we do? The approach that we're taking with storage is we're looking at to shift this towards moving storage costs into software-defined storage in two areas, around file-based storage. So the SMB protocol is really what's been lighting this up for Hyper-V storage over Ethernet networks, so that you can really now start to put workloads on an SMB scale-out file server. And in Server 2012, we enabled this for SQL Server workloads and for Hyper-V. And I've done some demos in the past where I can show a SQL workload running, and then we can take drop a NIC or something like that, and we still get that SQL workload will continue to run. SMB, allowing to run high-performance SMB applications over the network, gives us that ability to have file-based storage. And then, of course, my favorite one, Rick's favorite one, Macro's favorite one, Oren's favorite one is storage spaces. Okay, so this is basically creating a storage pool from just a bunch of disks, really, whether they be hard drives or whether they be SSDs. So it gives you that capability to create a storage space that it's an abstraction layer for the storage itself. And I'll show you, we'll take you through that in a bit around the demos in a second. The scenarios that we're looking at, of course, every release is all about performance, right? So faster enumeration. So we're using the standard SMIS protocol for connecting to these devices, so being able to manage them. This is a big piece of managing it within Virtual Machine Manager. We do real-time updates, out-of-band changes through SIM indications. For fiber channel support, we're going to support the Hyper-V virtual fiber channel in System Center 2012 R2, and we have fiber channel fabric discovery and zone provisioning. So from an ODX perspective, we are able to do bare metal deployments of virtual machines from, scale-out file servers in VMM, and ODX optimized virtual machine deployments, and optimized provisioning through differencing disks. So where are we going with this? You guys have probably heard this marketing term. Windows Server 2012 is cloud optimized. What does that actually mean? It's built really, in the networking session I showed a sort of a picture of one of our data centers. And really when we think about cloud optimizing, it's about building an operating system that will work across private clouds, hosting providers, and in the cloud itself. It's the same OS that we're running up in Windows Azure, and it's reducing your operational cost for storage. Because storage is the biggest piece. I think there was a number, Rick gave it, was a number we did in Sydney. It was, what was that system? It was about 5.1 million. It was a quote for a system that was $5.1 million all up. And the storage cost was 4.8 million in just the storage cost. So storage is a big piece. So we want to be able to stretch the investment that you've made in storage. Not have to make any changes at the storage layer, but get the availability that you would want to have for something, for a SAN. Okay, we want to have that kind of availability that you're used to in SAN-type environments. So when we look at our infrastructure, and this is the three things I want you to take away today around this from a storage perspective, is when we look at infrastructure as a storage from a vision perspective, we need to dramatically lower the cost of delivering storage services. It has to come down. We're going to decouple the compute and storage, and we want to be able to manage at scale each layer of that particular investment. And we want to make sure that you can use industry standard servers. You don't have to go out and buy special hardware. Of course, when you talk about those JBODs that Rick showed before in his session, is that there are certain JBODs that are certified on our Windows Server catalog, and you can go up to the Windows Server catalog and you can search for the term storage spaces. Those devices will be certified for storage spaces, and these are inexpensive shared JBODs. And this is really about your IOPS per dollar. It's about how much IOPS you're prepared to get, or you need to get, for how much you're going to spend for that. All right? And it's just a case of, say, if I had a JBOD enclosure here, and we're going to talk about tiering in a second, but I can get performance by adding 4 SSDs to a JBOD enclosure, to a bunch of hard drives, spinning hard drives. All right? So we'll talk about that a little bit later. So storage management for the private cloud. The pillars that we've got is around insight, flexibility, and automation. I'm not going to talk to each part of this, but Siri, what we're really talking about is end-to-end mapping, discovery, pool volume and files, share classification. And there's a whole bunch of things in this pillar to make sure that we're able to do block and file provisioning, scalable provisioning, extensive device support. We can do with System Center 2012 R2 is to do bare metal scale-out file server provisioning through PowerShell. All right, and there's the ability, and I'll show you some of the PowerShell that we do. What enables us to do this? There's a new architecture based on open standards, which is the SM Storage Management API. Okay, so this gives us 10 times faster enumeration. It's a single standard management interface for storage. Okay, it's an industry standard. It allows us to do added remoting and cluster awareness for managing storage spaces. And we added, this gives us the ability to have those new features such as write-back cache and tiering and storage tiering. And it allows us to bring the file server, the storage management capabilities in the file server role under management in Virtual Machine Manager. So we're able to manage our storage spaces and our scale-out file server through the SM API, being able to manage that directly in there. So that gives us that capability. And you can see in the slide here that we've got the ability to have Windows Server Manager, which Server Manager allows you to manage your storage spaces. That's your base way of managing that. And that does that through the SMB-based subsystem or the SMIS component subsystem. And then if you have an ISV or whatever storage, a compatible JBOD, it will use the storage management API through WMI to communicate to that device. And then we have, if we're doing System Center Virtual Machine Manager, it uses SIM pass-through to get to either our SMIS compliant NAS device or our fiber channel switch to manage all this directly. All right, and this gives us that ability to light that up. Then what we can do is we can bring our scale-out file servers under management. Okay, so we can go in and look at pool volume classification. We can create file shares. We can do echo management on our file shares, VM workload deployment to file shares. All that kind of stuff can be managed within Virtual Machine Manager. Bare metal deployment of the file server role, creation of a scale-out file server cluster. All this can be done within Virtual Machine Manager. This is our end-to-end management through Virtual Machine Manager 2012 R2. The name is a little bit misleading, Virtual Machine Manager. We haven't said this it's not a public name we're giving, but it should be really called Fabric Management, because it's managing not only virtual machines, it's managing your network. It's also managing your scale-out file server roles now. File share management. Do all your file share management from that one console. All right? Spaces provisioning. You can do all your storage pool creations, all your provisioning of all that, discovery of physical spindles. Mirror and parity spacing and deletion can be created there as well. I'm not sure if this was covered in the Hyper-V session, but we now have the ability to do shared VHDX. And essentially what this is it's taking guest clustering to a level where you don't have to have an iSCSI target anymore. So what this means is that with shared VHDX, provides shared storage for your guest cluster. And what it does is it presents this as a shared SAS disk in the virtual machine. So essentially allowing you to go in and add a virtual disk to a virtual machine and have that running across 3 different nodes at the same time. And it's just a tick box that you add and when you're adding the disk, you enable sharing. This needs to be sitting in a cluster shared volume or in a file. See here it's on a cluster shared volume for block storage or in a scale-out file for file-based storage. I have 2 options to do that. So I'm going to just make sure that this guy is still working. I'm a bit paranoid now. Just kind of move the mouse every couple of minutes because in 15 minutes my machine gets locked and I don't want to go through that again. So you get flexibility of your guest clustering. So that capability is there. So that really gives you that, when the VM looks at it, it's presented as a SAS disk. And it's scalable to create very large clusters, guest clusters in your environment. So shared VHD is really cool. iSCSI target server, a couple of changes that we've made to iSCSI's target server is around the ability to provision larger LUNs. So in Server 2012 and Hyper-V, we can have 64 terabyte VHDX files. Now we can have 64 terabyte LUNs in an iSCSI software target. And we can dynamically expand and shrink LUNs, logical units, while they're actually running. So it gives us that capability, a little bit more flexibility in the iSCSI target server. We can also manage iSCSI out of the box through the SMIS provider in Virtual Machine Manager. So we can add iSCSI targets in VMM. So again, bringing that iSCSI target under management into Virtual Machine Manager through that standards-based management. All right. Anybody have a guess what the average, you guys, how many were in the networking session earlier today? What's the average attention span of the average adult? About 12 minutes. How long are we in now? So it's time for a demo. You got to switch every now and again, otherwise adults get very, very bored. He said to just hit cut, I think. There we go. All right. So the first thing I want to show is give you an idea of what I've got in my environment here. So I've got a 2-node cluster where I'm running a bunch of virtual machines. So all of my VMs are sitting right now in a clustered shared volume. Okay, so I have a 2-node cluster that's connected back to a Dell EqualLogic iSCSI SAN device. And I've got all my storage sitting in a clustered shared volume. And I've got a guest cluster set up where I'm going to show you a scale-out file server and a couple of other things. So I've got an admin box DC, I've got an iSCSI target, and I've got 3 nodes in that cluster right now. Now each of those 3 nodes, I'm not using the iSCSI target right now as my storage for my nodes in this cluster. They're not being used for that. What I'm actually using is I'm using shared VHDX for this. So if I go and look at the settings for this, and you can notice that I've got data 1, data 2, and data 3 drives on this at this point in time. If I go and look at this, it's just a case of going down. This is really hard at this angle. Is to go down to advanced features, and all we need to do is enable virtual disk sharing here. And you do this at the time you're adding that virtual disk to your machine. Enable virtual disk sharing. That has to be either sitting on a scale-out file server or in a CSV. So I'm going to just escape. Oh, excellent. That's just a momentary pause in broadcasting. And we've got a number of data drives that we're using on this. Okay, so if I go to my second node in the cluster, you will see that those same drives are attached to this virtual machine. So through shared VHDX, we're able to enable those VMs to be running for guest clustering, and I don't have to have an iSCSI target there. So how is it presented to that one? So I'm going to connect up to one of my nodes. So just log into this guy. Actually, let me switch over, go over to my admin box, because that's the one I want to be on. So how is this presented to the operating system? So what you're going to see here is that here's my server manager with my storage pools, and I've got all my spaces that are created on this particular device. Now, you might notice that this is a storage pool created within a VM. Not supported, all right? You can do it, and there's a great blog post on how you can set it up, and I think that's what your demo shows. But this is not a supported scenario. It's a great way for you to test this out in your environments to see how this works, but it's not a supported scenario. But what you notice there is I've got all my disks actually set up for my storage pool and my space, and you'll see that these disks, these 19 gig disks or these 20 gig disks are presented as SAS disks when they're set up as shared VHDX. Okay, they're set up on the SAS disk, the bus, and those are presented to the operating system so I can go and create my cluster. Now, so that's shared VHDX. The next thing I want to actually show you is the way that we actually can now manage this all through VMM. Okay, so we have the ability now to, at the fabric layer, we're able to bring storage under management at the fabric layer. All right, so what this means here is that if you go down to the fabric layer in VMM, we can go up and we can set our different classification pools. We can create storage pools from here. We can go and, you can see here, we can go and create a file server cluster. We can go and create a file share. And you see here I've already got, it's bringing my storage pool, which I just showed you in Server Manager, bringing that under management in Virtual Machine Manager. And essentially what I've got here is I can go in here and I can see I've got my scale-out file server has been added to Virtual Machine Manager. Now that scale-out file server has been created, and this is all through PowerShell. I have a scale-out file server running on my cluster, and I've got a bunch of disks that are currently being used in a cluster shared volume. And that's now all been brought up, and I've got a cluster pool that's been set up here as well. And that's all been brought up under management through the SMIS, through the SM API to be able to see that through Virtual Machine Manager. And we can do that through Fabric resources. I can go here and I can create a file share. I can go and add a storage device. Now, it allows me to go and add a storage device for a number of different options here. I can go and add a storage device for a Windows-based file server, SAN or NAS device discovered by SMIS. SAN device is managed by the native SMP or the Fiber Channel Fabric discovered. So you have those different options to be able to connect and add those in. Now, I've already added that in, so I can go and look at, I'll say yes to that. And I can go and look at the properties. I can go and see the number of cluster nodes. So I've got 2 cluster nodes on this right now. All right, so I've got 2 cluster nodes on this. I'm going to show something a little bit later on. And I've gone in and I've classified all my my shares with gold, silver, depending upon how I want to make this available to my customers. And so I can go and specify that if I want to. I can go and manage my. Sorry, I'm going to get a remote desktop disconnection. No beauty. easily fixed. We'll just disconnect. All right, so we can go down here and we can go and manage our pools. So we can go and create a new storage pool from here. We can specify classification for this pool. Okay, so if we wanted to say this was the NZ pool, NZ pool, and I can then go and classify that pool. We'll say this is a gold pool, and we'll choose create. It's going to say obviously that there needs to be a bunch of disks to be able to create that. But if I wanted to go, if I had some disks in the primordial pool, that would allow me to create that pool directly from Virtual Machine Manager. We can go and look at fiber channel fabrics. We can go look at our file servers and also look at our arrays. And then you can see the providers. You see I've got my cluster storage space. This is my role that's being, that Windows file server that's been added. That's one of my providers. And we can go and look at connection settings. We can see what the connection, what storage arrays actually say, get your total capacity. So total management within Virtual Machine Manager of your file server roles that you want to have. I'm going to be doing some other stuff in this a little bit later, but I just want to show you that first part, and then we'll come back to that in a second and show you a little bit more of that. Okay. So the next piece is around file-based storage and the scale-out file server role. In 2012, we introduced technology called SMB Direct for allowing us to actually use very high performance network cards over RDMA, and these are your 56 gig InfiniBand type cards. And one of the big changes that we got a lot of feedback from customers is that, look, I'm doing a lot of random I/O workloads. And we worked really hard on the R2 release to make sure that lots of random I/O workloads that a lot of customers are using is improved. So we improved our 8K IOPS, 300K IOPS to 450K IOPS per interface. Okay, so in Server 2012, we were at 8K IOPS per interface. That's been roughly between 300 and 450K IOPS improvement. So it's around about a 50% improvement on random 8K smaller reads. We increased efficiency with small IOs, such as OLTP databases that are making lots of small changes, lots of database changes in a VM. And we optimized 40 gig Ethernet and 56 gig InfiniBand. So a lot of changes there in regards to optimizing that through the SMB Direct protocol. The other thing we did is around optimizing rebalancing of scale-out file servers. In Windows Server 2012, there was no way to, the storage and the shares and the way that they were actually redirected, they were kind of random in the way that you had to balance these across the different nodes in your clusters. Okay, so scale-out file server clients are now redirected to the best node for access. And this is really to avoid a lot of the redirection traffic that we used to have in Server 2012 in regards to our clusters. Okay, so this is driven by who has ownership of the cluster shared volume. And SMB connections can be managed per share as opposed to being managed on a per file server. We can dynamically move that CSV for balancing points of view, and this is automated. There's no administrator action in regards to this. I don't know if you noticed when I went into Cluster Administrator that I had 6 shared CSV volumes, and 3 of them were on node 1 and 3 of them were on node 2. There was nothing I had to do in regards to that. Nothing at all I had to do at that point in time. There was no behavior. It just automatically balances that for you. So it optimizes the rebalancing of scale-out file servers. When you start, when you add that, it will automatically rebalance that particular workload. Hyper-V Live migration over SMB. So a couple of things we added here in regards to make this better is in regards to compression. So we do 2 ways we actually do this. We can do SMB, which is your RDMA setting. So if you have RDMA cards, you can set that setting to SMB, and that will live migrate virtual machines a lot quicker. Why does it matter if you can live migrate a machine a little bit quicker? If you have to do this in VDI environments, it's a big deal. Compression is the other one. We also do compression for live migration of those VMs. and it can take advantage of all those high-speed networking capabilities. So being able to live migrate over SMB, another thing that's lighting up from a storage perspective. SMB bandwidth management. So on a common infrastructure, what we're doing here is to be able to, SMB is being leveraged to manage access to storage in the distribution of those VMs. So it's configurable. We can, this is really on the hosters to control different types of SMB traffic that they've got. And we can set bandwidth limits per category on those devices. So the other thing we can do is we can expand or shrink a VHD with no downtime. So if you need to expand this, you can go and set this. The other thing that you're going to want to probably do, and I think Ben showed this in the Hyper-V session, I believe, is around maximum IOPS on your VM. Okay, so what this does is allows you to set a limit on the IOPS that you want on a per virtual disk basis, or in the minimum IOPS alert. Okay, so this allows you to really start to do storage quals for all of your virtual machines, to be able to limit the storage that's going to come in and out of that VM. So that's a really good thing that's been added in R2 as well. Now let's show you how we can automatically load balance these scale-out file servers. All right. Okay, right now what you're actually seeing is I have a bunch of CSV disks, and you notice here that those CSV disks right now are balanced across node 1 and node 2. All right, so I have 7 in this particular scenario. 4 of them are on node 1, and 3 of them are on node 2. I haven't had to do anything here. It's automatically gone and balanced these out for me. All right, so now I can go in. Now, what I'm going to do is I'm going to go and manage this and go and add my third node in the cluster, because if you look at my nodes in the cluster, I've got 2 nodes in the cluster, but I've got 3 nodes in my environment. So instead of going and adding that through Cluster Manager, I'm going to go to VMM, I'm going to go to my cluster nodes, and I'm going to go and add this. Now, you don't get to go and browse. You have to know the name of the cluster node here. All right, so you're going to have to type in the fully qualified name for this, so you need to obviously get it right. And we're going to add that guy there. Okay, so this is going to go and do a whole bunch of things. So let's go and look at our jobs. And we're going to add this, and you can see what's going on in the background. All right, so let's click on this guy. And you can see there's a bunch of stuff going on right now. So first of all is to add the node to the file server. And we do this in parallel execution. So you'll see a lot more details of what's going on. So what we're doing now is we're going to add the node to the file server. There's a parallel execution step. We've got to prepare the storage node. And then what you'll actually end up seeing at the end of this is it's going to go and balance the CSVs across all 3 nodes. So it's going to look at those 7 disks, and it's going to automatically rebalance that so that our scale-out file server will be used across all 3 of those. Now, this is what it's doing now is first of all installing the Virtual Machine Manager agent on that box, which went faster when I was doing it before. What I might do is kick that off, come back to it. Nothing worse than watching, and my mouse has died. There you go. I can't cop a break today. So I'm going to come back to that. I'll kick that off, and then you'll see what happened at the end of that, so you can see how that actually balanced out. I'll watch it and see where it's actually up to at that point in time. All right. Cool. So you can do that all from within Virtual Machine Manager. Go and add nodes to the cluster. You don't have to use Cluster Administrator, so you can go through and use Virtual Machine Manager for that. Data deduplication. So you guys said you had data in your environment. How much of it do you think is duplicated? How much? 80% is duplicated. All right. Bit of background on data deduplication, and essentially what we did in Server 2012 around data deduplication is it allowed us to dedupe files that were had similar chunks. And essentially what we do is we do deduplication on, say, data stores. And we look, say, for example, we look at files that are pretty much the same, that have the right same blocks, and we put those into the chunk store. Okay, so what that does, and we run a dedupe job on that particular volume. And what we do at that point in time is that we go and look at that volume, we look for duplicate chunks, and we put them into the chunk store. We only write that file, we only store that file once. And we see in a lot of customers that have so far used dedupe, we see anywhere from 50 to 90% savings in duplicated files. So customers are realizing 50 to 90% of savings in regards to dedupe. Now, in Server 2012, we couldn't do deduplication of open VHDX or VHD files. So we've added that in Server 2012 R2. Kind of. I don't mean kind of in the sense that you can't do it with everything. It's generally designed for VDI type workloads. Okay, so you can do it on other types of workloads, but it's designed to be used for VDI type scenarios. Why is that important? Because when you looking at VDI, what's the common characteristics of a VDI environment? Every virtual machine has probably got the same components in there. You basically have a base VHDX or VHD file that's going to be the same, pretty much, right? And it's going to have the same files in it. Okay, so what we do with that is we're able to go in and dedupe a volume for VDI. And what that means is that we're going to see space savings up to 90% on VDI deployment. So it means you can get more VDI workloads running, and it means that you can not affect the impact of that workload. Okay, so the other thing is that, say, a lot of people ask, what if I'm running a bunch of dedupe VMs? How's that going to impact startup times? What we do with that is we actually we're able to start those dedupe VMs faster than we can start our undeduped VMs. Okay, because the way we store those files in the chunk store, it's faster to load it out of the chunk store once than having to load it multiple times. And in a VDI environment, that's important because what it means is that the user is at their desktop, has an IP address faster, so that they get their workload faster. So performance, we have faster read and write of the optimization. So in dedupe itself, we go in and we can run a dedupe job. Essentially, you can set a schedule for dedupe, how often you want to do background deduplication, how often you want to do throughput deduplication as well. So with that, we've improved that optimization speed. All right, you can do this through a PowerShell script, start-dedupe job, and your type is optimization and the volume you want to do that on. Okay, so it's fairly simple to go through and actually do that. We support scale-out file server with cluster shared volumes for this as well. So dedupe is now working on live VMs. All right, so that is really helpful in the sense that you can, for those VDI type environments. So I'm going to show you this in a second to see the difference between the savings that we're actually getting. So this is almost done. It's about 70% of the way through. So let's have a look at data deduplication real quick so you can see that. And let me just switch over. All right, so you can see with my adding my node to the cluster, it's done a few things. It's gone through and added, enabled the file server role. If we refresh this component in the cluster, we probably should see our node added to the cluster. And let's refresh this guy. It's not quite there. It's almost ready to go, but it's almost there. All right. So I'm going to go over to another box where I have deduplication enabled. All right. So I have this particular machine is a Lenovo W510 laptop with 2 SSDs in it. One for the operating system, one for the disk. I got an OCZ Vertex 4 in there for the disk. I've deduped 400 gig of that drive, and I've left the other part undeduped. And you can see I've got a bunch of VMs that are currently running. Those VMs right now are all running on the deduped volume. I haven't noticed any performance degradation on those VMs themselves. All those VMs are running on the deduped volume. So I'm just going to go over to Server Manager real quick. And what you can notice here, and I want you to look at that percentage that I've got going on here. Okay? It's a 400 gig partition. I'm getting 65% savings because it's mostly made up of VHDX files. All of that, most of those files are pretty much the same. All right, and when I first set this up, all I did is I kicked off a dedupe job, which is start-dedupe job. The type is optimization and the volume we want to run that on. And I get a savings. Now, Macro and I, we had to buy another disk because we were running out of disks for all these different events that we have to run. Now I can actually use this all on one disk. I've been able to actually save myself about a 500 gig SSD just by enabling dedupe on all my volumes for demos. So now let's go and have a look at the folder here. You can see this is where all my images are. And these are all my VHDX files that I currently have running. And let's go and have a look at the size on disk versus the space that it's taking up. Look at that. That is amazing. Size is 316 gig. Size on disk is 39 gig. That is cool. I love that. It saved us, people that do demos all the time. It saves us an enormous amount of space being able to do this. And because we can do it, well, technically we're only supposed to be doing it in VDI type scenarios, but it seems to work okay, so I'm not too stressed about that. And essentially what you do to enable this, it's basically doing this at the volume level. Oh boy. I can almost predict this now. I'm getting into such a rhythm that I can almost predict whenever I try to do something, it's just going to disconnect. I'm just going to go with the fact that the demo gods are nailing me today. I don't know. It happened. Hey? Maybe. I don't know. Anyway, so it's essentially to configure data deduplication. It's very simple. You go and configure data deduplication on this volume, and you can do it for a general purpose file server, which is what we had in Server 2012. Now you can do it for a VDI server, okay? So for Hyper-V on a VDI type scenario. Now I've already done that, okay? And let's go over to my D drive, which I've already done that on. And I'm going to go configure data deduplication. Now with data deduplication, I've set it up for data deduplication, duplicate files older than 1 day. If you want your dedupe job to kick off straight away, set that to 0. If you don't want to do a start-dedupe job-optimization, right? So you set that to 0, that'll go. Now, we really haven't changed much in the deduplication schedule, but what you can do is you can create, the way that by default is we do background optimization, okay? Then you can create a separate schedule that you can set off hours, okay? So say in the middle of the night where you're actually going to do throughput optimization. Okay, so with throughput optimization, that will take over more CPU cycles, and it'll go and run that dedupe. It'll pretty much do the same thing as a start dedupe job does on an optimization. And then you can create a second schedule for throughput optimization, so it gives you that finer granularity to actually do that as well. So I'm going to open up our good friend, PowerShell. Everybody loves PowerShell, right? Yeah, woo! PowerShell rocks. Now don't try this at home, folks. I'm going to start a dedupe job on my running VMs. Okay? All right, so I'm going to go and run this dedupe job on my VMs that are currently running. All right, it's queued in. And I'm doing the type optimization. Let's go and see how that's actually going. Oh, I just missed that. There we go. Okay, it's currently running. Let's go look at our VMs. Not being really affected by this at all. Go and search, blah, blah, blah. Be careful whenever you put up anonymous if you're doing a demo, because you never know what you're going to get. So you look, the user's using their virtual machine. We're running a dedupe job in the background. It's not affecting the workload of this at all. Right? So dedupe is actually working. All right, so the key thing that we want to make sure of is that when you're in a VDI environment that we're safe to be able to run a dedupe job and not affect that workload that's currently running on that machine. All right? So dedupe rocks, go out and use it and save a whole bunch of space and not have to buy a bunch of new hard drives that you really don't need. So let's move back into our next good friend, which is storage spaces. Now, Rick covered this in his his storage spaces thing. So I'm not going to reiterate that too much, but for those of you that weren't actually there, we'll go through and cover a couple of things. So storage spaces, some of the things that we've done in R2 is around this reduced time to recovery. The mirrored spaces rebuild time has added this new feature called parallelized recovery, which allows you to recover that workspace in a dramatically less time. So our mean time to recovery has been dropped down dramatically. We also have increased throughput. So you look at this particular metric, we've got data rebuilt in 49 minutes for a 400 gig. I think it's 400 gig. So this was showing 3 terabyte hard drives, two-way, 4-column mirror space, and that was some internal testing that was done, and it allowed us to rebuild that fairly quickly. So if you have a disk that fails within your storage pool, your mean time to recovery is dramatically reduced. The next big thing, and I'm going to show you a demo. Rick showed you how to actually configure your storage tiering, but Storage Spaces now has this notion of called storage tiering. This is about being able to place the data, depending upon whether that data is hot or whether it's cold, and move the hot data up to the SSD tier, to your faster tier. So essentially what this allows you to do is to create a storage pool, okay, or a storage space with a mixture of SSDs and hard drives. And we will automatically, as the data gets hot, so if somebody's accessing data within a virtual machine, say it's a SQL workload, the data gets hot, we'll move that hot data up into the SSD tier. Okay, so that's moved. And we do this at the sub-file level for data movement. Okay, and we complement this with write-back cache. Now, if you get a lot of I/O spikes within a workload, write-back cache is going to protect you. All right, and I'll talk a little bit about write-back cache in a second. And also the administrator can control how they pin workloads to the SSD or the HDD tier. Say if you have a workload that needs better performance, you can move that down into pin it to the SSD tier. And this is made up, when you look at storage tiering, this is about making this up with standard enterprise 7200 RPM hard drives, 3 terabyte drives or 4 terabyte drives, and then standard enterprise SSDs. And typically the sweet spot is around 4 to 12 SSDs that you have to add. I think this, Rick, the scenario you used was 4 SSDs in your scenario that gave you that better performance. And we're going to show you that in a bit of a demo in a second so you can see it. So this is really probably one of the best features in storage right now in R2 is the ability to put these up in different tiers. And we're going to show you how to move them around to the different tiers as well in a second. So in this particular scenario, we have HDD tier with our 4 terabyte SAS drives and our 4 SSD drives. Dramatically drops the IOPS per dollar for your storage needs. Okay, so this is commodity-based hardware. Now, the other thing is around write-back cache. Okay, so write-back cache is about being able to respond to spikes in I/O. Okay, so a workload might get a spike in that particular I/O, and what this does is to be able to, there's always going to be storage access patterns where you're going to get more I/O happening. That can impact how the workload is actually running. Okay, so SSDs provide higher IOPS for random access, such as SQL I/O and all that kind of stuff. What this means is that the write-back cache, which by default we set the write-back cache to 1 gig when we go through and create our tiered storage. You can go and increase that as you need to. In the demo we're going to show you, we created, I think, a 6 gig write-back cache for a high IOPS application. And it's seamless integration. It's on by default. You can turn it off if you want to. Okay, so if you don't want write-back cache on a particular tier, you can turn that off. All right, so that gives you that option to do that. So does anybody want to actually see write-back cache and storage tiering? Anybody interested in that? Yes? No? Maybe? Could be? All right, let's have a look. It's just life in the big city at the moment. I'm just gonna roll with it, man. What can I do, eh? Oh no, that one's actually all right. This one's okay. All right, so this one's fine. This is the one you set up for. This is the one we set up, right? So, all right, let's look at. Rick showed you a whole bunch of stuff on what it looks like from a PowerShell perspective. I'm going to take through and show you. Look, I've got a bunch of SSDs. I've got my 3 terabyte spinning hard drives, and you notice that I've got a couple of storage spaces that have already been created. I've got one called WBC, which is my write-back cache storage space that has write-back cache enabled. I have another partition, 100 gig partition with no write-back cache enabled, and I already have a tiered storage space that I've created, and that tiered storage space is a mixture of HDDs and a mixture of SSDs. So it's pretty simple to create a pool. Hopefully you guys all know how to create a pool. It's very, very, very simple to create a pool. You simply go in and go task, new pool. We've already done that. We've created a demo pool. All right, and what that does is a demo pool. To create a pool, you have to have disks that are in what we call the primordial pool. Now, the primordial pool is that those disks are presented. Do you know what primordial stands for? It's the oldest thing of time. Apparently, it's something to do with dinosaurs or something. I don't know. Product teams go out and they get really pissed, and they come up with these really weird names. You know, they go bar hopping. They go, oh, let's call it the primordial pool. That sounds like a good idea. Anyway, so add that in. Those disks have to be unallocated disks to any other pool, and they can't be allocated to Windows. They have to be raw storage. Okay, so in order for you to create a storage pool. Now, we've already created our storage pool. All right, so we've got our demo pool, which is consisting of 22 terabytes of capacity. I want to go and create a tiered storage space. Okay, so what I'm going to do is I can go and create a new virtual disk. And this is the UI of what was showed earlier in the storage session in regards to showed in PowerShell. So you can notice we'll call this the NZ. Why do I keep talking in X? I don't know. NZ space. And you notice we have a new option here. Okay, so what this is recognized is that we are reporting to the operating system that these disks are SSD, and we have a mixture of HDDs. Okay, so now what it allows me to actually do is to create tiers on this virtual disk. All right, so we're going to go and tick that box, and we're going to hit next. And you have the option to do a mirror. All right, we're going to do a three-way mirror. Okay, now when you turn on the option for tiering, it's only fixed storage in the R2 release. In Server 2012, we implemented this new option for thin provisioning so that you didn't have to allocate all your storage up front. In a storage tier, you have to allocate that storage up front. Okay, that's just something to notice why that's actually grayed out. Now, here's where we get the option to specify how much we want to have on the faster SSD tier and how much we want to have on the standard tier. Okay, it shows you the amount of space that's free on that, and you can go and say, okay, well, I want this to be, 100, we'll say 50 gig on this one. And we're going to do, we'll say 500 gig on this one. And all the provisioning will happen in the background for you, and we go and create that, and now we have our tiered storage. Now, at 1 o'clock every night, we will run a job that will go and look at the data that's there, look at the data that's hot and cold, and it'll move the hot data at 1 o'clock in the morning. It's a scheduled task that runs every evening to move that data that's hot up into the SSD tier. And you can go and control that as well. So I'm not going to create a volume on this. I'm just going to leave this for the time being. We can do that later. So we'll cancel out of that. Now let's have that's not the one I wanted. Look at a demo that we want to run. That we're going to run storage tiering. So we're going to run a write-back cache demo and then storage tiering. So what we're going to do is we're going to run a write-back cache demo to show you what the impact is when we put some spikes on that workload. So luckily this is, and I love the ASCII text that they use for this. This was a very impressive thing to be able to have ASCII text. Can you imagine the dude that sat down and did this? How much he would have had to actually write. So anyway, so what this is going to do, this is our write-back cache demo. And what we're going to do here is, remember before I showed you I had two different volumes. Okay, so I had a write-back cache volume and a non-write-back cache volume. What you're going to notice here is that we're getting Around about almost 600 IOPS on this particular workload, and everything seems to be going along fine. Okay, so our workload's fine. On the left-hand side, we've got a volume with write-back cache, and we've got a volume without write-back cache. All right, everything looks fine. Now we're going to go and introduce a spike to this particular workload. That came out really loud when I said that. Sorry about that. I just like the word spike, right? All right, so let's go and introduce a spike to this. Now what you're going to see here is that the volume with the write-back cache is going to absorb this, this additional spike in how it's actually running. We're not going to impact that. But what did you notice on the one without the write-back cache? Our workload was affected. Okay, so what you're going to end up, what does that translate to? Numpty's ringing you up saying that the application is down, the internet's down, blah, 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 blah. It means you're going to have more help desk calls, right? That costs you money. If we can avoid this by having the write-back cache in there, we can absorb that workload. The write-back cache is actually absorbing that workload. Let's go and smack this application a little bit more so we can see what it's going to look like. So hit it with a couple more spikes. Let's smack it around a little bit. What you're going to see is the write-back cache is going to do its job. It's going to absorb that, and it absorbs this at the SSD tier. Okay, so it's going to absorb this particular, and you see our workload without the write-back cache on that disk has been affected by this SQL I/O. Okay, so that's pretty cool, being able to do that so that you don't have to, your workloads are going to continue on with write-back cache. That's on by default when you set up, you want to clap, do you? Hey, look, I should get points. This one worked compared to the networking one, right? So, yeah, anyway. All right, so I'm going to move on to the tiering demo, and this one is really interesting as well. Now, we have a workload that's currently running, and we've got to go and set up the tiering demo. What I'm going to do is I'm running some PowerShell script in the background. It's going to close all the write-back cache demo off, and it's going to prepare the tiering demo. It's going to have some ASCII text for you so you know which demo we're on, which is very good so you can remember. So we'll just wait while this actually prepares this demo. There's the tiering demo in case you were not clear on that. So we're going to do a similar thing here with the tiering demo. We're going to load up a workload. And on the right-hand side, what you're going to see is that this workload is currently getting around 11 to 1200 IOPS. It's what we would expect if that application, the particular workload, which is a SQL I/O workload, it's what we would expect running on spinning disks, right? So, you know, but this data is becoming hot, and so we're going to look at moving this up to the SSD tier to get better performance. Okay, so you notice that it's running pretty flat at this point in time. It's getting around it's staying right around that 1100 average. Now, what we can do is through PowerShell is we can go and move that particular workload or portions of that workload up into the SSD tier. Okay, so that we can get better performance. So let's go ahead and do that. So we're going to go, I'll make sure I get back into my PowerShell thing. We're just going to go, we got a VHD file that we're going to move up into the SSD tier. This is background data movement. Now watch that counter. That counter is going to move up steadily. Steadily. It'll go. Never does it at the same time. But you notice the IOPS are starting to increase, and the little curve is going up higher and higher. Things are getting better. Less users are calling. You get to go to the pub. Look at that. Awesome. And it gets all the way up to 20,000 IOPS from about 1100. Woo! Is that good? And that took 24 seconds to move that from the HDD tier up to the SSD tier. Okay, so pretty fast. And it means that we take our hot blocks and we move that up into the faster tier. This is all done in this scenario. How many HDDs do we have in this? No, SSDs, I know we have 4 of those. 8. So we have 8 hard drives in our cluster in a box that we've got set up back in Redmond, in Seattle. And we've got 4 SSDs. So we were able to increase our IOPS just by adding 4 SSDs to that enclosure. So that's a pretty good bang for your buck type scenario. When you think about how much storage costs, how much SANs cost these days, this gives you a really good bang for your buck in regards to the IOPS that you're able to get by just adding a few SSDs and creating a tiering type storage space. So we think that's pretty cool and something that we see a lot of businesses taking advantage of. So I like that one. That one's Awesome. Oh my God, it's 10 past 4. Crap. Okay. So just to summarize, a whole bunch of stuff in Server 2012 R2 that helps us improve, focused on the areas around performance, scalability, reliability. I love the icon they've got for the dude with the muscles. I don't know how many IT guys you see with muscles like that, but anyway. Being able to grow or shrink our VHDs, lots of improvements that we've seen. And really the focus is to allow you to use your commodity-based hardware, not make any changes to the existing hardware, but get better performance, get better IOPS for less dollars. So we hope that's going to be a compelling thing for you when you look at R2 from a storage point of view. I don't think I put any storage in there, but just wanted to make sure you guys fill out the evaluations to win instantly. Now, I have to apparently give away... Hey, Rick, you want to help me give away this thing? Now, settle down. First person, what's the default write-back cache size?
1 GB.
Who said that? Who said?
1 GB.
1 G? Come up, you get a phone. Congratulations, sir. Thank you for coming. Thank you guys for taking the time out to come to this session. I know you've got a lot of sessions that you have to pick through in the day, so I appreciate you taking the time and coming and listening to storage. And thanks for having me in New Zealand. I had a great time. Thanks, guys. Bye.